So I'm Tim Ventura. I'm here with Mark Sokol and the Falcon Space team. Introduce the teammates, sir.
Over here we have Jatine. There's Pinky.
Pinky the
Say
dog.
hi. The dog.
He's getting bigger
And
though.
There's she is.
Yeah, I think so. Looks like it. Yeah, look at that.
Hi.
She's a Zoom hound.
Yeah, every time she sees I'm on a call. She comes running.
It's
And
late
that's,
your time,
Tom
man.
Butler.
What? It's like 1 a.m. there.
Yeah, it's 1 a.m. and we're all staring at this oven over here. It's we're cooking up some aluminum discs, and I have oxygen going in. I have this low flow controller, and it's going into a little.
So Mark, can you
tube
give
up
me
there.
a tour? Can you give me a tour of the world's first anti-gravity lab? Got to give me the grand tour.
Okay, so here we go. We got the Faraday cage, and we got some experiments going on inside of it. I don't know if you can see that, but there's a thin fishing line that heads up to the ceiling, and above that is a super accurate scale up on top over there that connects to our mainframe computer for giving us live data of whatever experiment we're working on. And over here, radiation suits, temperature, camera, and here's all the gizmos and gadgets that make the Alzofon experiment work, such as our signal generator, amplifier that we mixed off of Sandia Labs. We got high voltage power supplies, low voltage, high current for the electromagnet, a large electromagnet in there. Got a scope up here, and up there on top you can see different variations of the gravity flyer and our warp engine. That's another project that's going on over here.
Yeah, and I understand Charlie just got more Graviflyer stuff from Alexei in Russia.
It wasn't Charlie that got it. That was Russell Anderson down in in Florida, down in sunny Florida. He just got some more of that stuff. Here we have this is the scalar magnetic field generating device, and it's gadgets and gizmos. And underneath is a battery that powers that thing. And here we have, this is some oven that I got trying to make, we're trying to make oxide layers on the aluminum samples that I've been vapor depositing. And as you can see, it didn't come out very well. It started off by cracking, and then the metal just sort of liquefied and bubbled up.
That looks pretty good. Have you asked Tony about that? Tony's worked with that, kiln-fired superconductors.
This is not kiln-fired superconductors. We're trying to make oxide layers on different metals. And right when you called, I was actually in the middle of sending an email to Bernie about the iodizing process, which seems to probably be the way to go. So we wouldn't be using heat, we'd just be using some sort of aqueous solution where you put the sample in and it just applies oxygen directly to the anode. That's why it's called anodizing. And that can be done with a variety of metals, including magnesium and zinc, although I haven't seen any paperwork about doing it with bismuth, but I'm imagining that that would be actually the way to go to do this properly. Now, over here we have clean room and our vapor deposition machine. And I can step inside real quick and just give you a quick tour of what we're doing in there.
Mark, I'm really impressed. The work you guys have done is amazing.
Maybe I should do something like this on Apex, just give everyone a tour of what it looks like in here, because normally I just do it straight from the computer. So here we are inside. There's nothing going on in there. There is a vacuum though. We pulled the vacuum earlier, and we were running these discs before and plating them with aluminum. You can see there These are nice aluminum plated samples. Plated them on both sides, and you can see.
Yeah, it's really smooth.
Yeah, it's like super shiny. Oh, another thing I just picked up off of eBay was a spare one of these bell jars, vacuum bell jars. So after each vapor depositing process, the bell jar gets dirty. Some of the vapor ends up on it, and you end up just looking at a mirror. So you have to take it off and clean it each time. So what I did is I got a spare one. So while they're cleaning it, I can be using the clean one. You just keep swapping them out and continue our vapor depositing process.
Okay.
So that's what's going on over there. Now I'm just inside the ant chamber here where they have sticky floors, trying to keep everything clean inside of the clean room.
Yeah, I'm really impressed. The amount of work and the quality of work that you guys have done inside a relatively small area is impressive.
And in a short amount of time too.
This is, Mark, what you guys are doing is a historic first. You know, I'm not exactly sure for what, but it's historic first. It goes down in the history books. We'll put it like that. I'm not sure where it goes under, but it goes someplace.
Well, if something comes out of this, it'll definitely be in the history books. No doubt about that. This is our laser interferometer, aka the warp drive detector, a warp field detector. What's special about this one is the base plate is made out of a dielectric. It's a very strong type of hard plastic. Back over here, this is a project that me and Jeremiah worked on. It's a 1 million volt March generator.
Wow.
Just charge that up with 30,000 volts and it puts out a big whoop of energy.
And so you can use that for Podklenov. You can discharge that through the Helmholtz.
That's literally what it was built for. It was built for, this is not going through the Helmholtz. Helmholtz is going to get a battery to power it. This is going to go, the 1 million volts is going to go to the spark gap with the superconductors in it inside the vacuum chamber, the acrylic tube vacuum chamber. So back over here, we have a little air conditioner that's keeping the clean room nice and dry and cold. Over here, we have various machining equipment. This is a Klystron setup from one of our earlier attempts at Alzofon. This Klystron is broken. It needs to be vacuumed better. There's some more machining equipment, sanding, buffing, cutting. And over here is the CNC machine, which you may have seen before. We have the 4th axis hooked up right now. And this is where we do most of the machining work for various experiments. When we need something of a certain size or made out of metal, we stick it in here and program it and cut it out. This is how the scalar magnetic field generator was created. It was right here in the CNC machine. We made some pretty impressive stuff on it. Did I ever tell you about the polar bear that I made?
Mm-mm.
I took a block of aluminum and cut it out into the shape of a polar bear.
Okay.
Nope.
So it can do it just 3 dimensions then, right? It's 3-dimensional axis, it tilts and yeah,
with the 4th axis. Well, that was a pretty difficult job. That was just for practice to figure out how to use it. Here's our welding station. Hasn't been used much, to be honest. Not many of the processes we're doing so far really require welding, but we do have a welding station. We do use it for some structural stuff. And these 2 tables, this is for tools for the machine. And this
CNC
is
bits
for work holding. You guys are out? Yep. See you tomorrow. Good night, Gene.
Well, Mark, thank you for the tour. Thank you for giving me the tour. You guys have a lot of stuff. I'm not kidding. I'm genuinely impressed. What you guys have put together is pretty remarkable.
You want to see something really cool? This is something I've never shown on APEC before, but with the battery business, one of the main pieces of equipment that I put together. I actually designed this and went through many iterations until it came to this point. We call it UBT. You see the sign over there. That stands for Ultimate Battery Tester.
Okay.
And right in here, this is the machine. It's basically 34 channels of individual charge discharge with temperature cutoff. So there's a temperature sensor that goes into each module separately. And when the temperature reaches a certain temperature, it shuts off the charge and goes into discharge using resistive loads. So all of that energy is going out as heat into these vacuum things over here. Into this, basically venting it outward. This machine is actually one of the most complex things I've ever built in design.
Yeah, because it's massively parallel.
Not just that, the software that runs it had some sort of issue with once you get past like 13 or 14 modules on a computer, it started to have kernel memory overload. And we couldn't figure out a way around that. So what we did is we just used 3 computers. They're in the base of this machine, and they're all connected with a program called Mouse Without Borders. So you have 1 mouse and 1 keyboard controlling 3 computers. 3 screens over there actually represent 1 computer per screen.
Okay.
And that gives you charge discharge time.
Now, Mark, I have something to show you. I have something to show you. Since we're talking about EVs, maybe we can do an unboxing.
Woo!
Of my wall connector. Yes. And you have no idea how much the electrician said they wanted to charge. They said $700 to put this on the wall. And yeah, I don't even know what's in it. I haven't opened it yet. Here, let's open it up and see what's in it. You can watch me cry. I'll cry live on air. Okay, and oops. Okay, and that's it. That's our wall connector. So this looks like a giant mouse. I swear to God. In fact, let's see. Basically, it's a giant mouse. This is a giant Apple mouse. Whoa.
Sweet.
That's, yeah,
What,
so that's, this was
why is
400.
it $700?
It was 425 for the unit. And there's only one place in town that says they do it. They said their prices start at 700. And so I called their competitor. I'll get a quote tomorrow.
Okay, I mean, I installed mine myself. Had to drill a hole through the house. And the wire alone was probably, I don't know, $60. But it was a very short run. It was literally right next to the board.
Yeah, mine's distance, like 3 feet. 3 feet out the back.
It was 3 feet out the back. Okay, yeah. So you could probably wire it yourself if you go into the board. I could help you. Pretty simple.
And then I think it needs like a 50 amp breaker, right? Or something.
50 amp breaker, you probably get 6 or 8 gauge wire. And you just run it through the wall and plug it in and should be good to go. You need to get both phases.
Yeah. So yeah, I'm not going to do it myself, but I'll find a competitive electrician. I would bet you, I could probably get it done for half, right? I mean, it's a wall charger.
I bet you probably could do. Okay, so yeah, take it from the top. So basically, what we got over here is a oven. This is a high temperature oven used in dentist offices, and it goes up to about 1100 degrees centigrade or 2000 degrees Fahrenheit. It's a pretty hot oven. And we have a ceramic disc in there that's been plated with aluminum. and we're trying to create an oxide layer on the aluminum. So what we're doing is we're warming up the disc to about 400 degrees centigrade, and we're pumping it full of oxygen. So the chamber is going to be full of oxygen while this happens. And hopefully there'll be some sort of oxide layer and we won't crack the disc like last time. We got the oxygen over here in this big tank feeding through that tube, and it goes to alumina tube, which is aluminum oxide already. Aluminum oxide actually is a very good, useful material for high temperature. Sort of comes like a ceramic material. It can be pretty hard too.
Isn't that incredibly explosive, Mark?
Corrosive, not explosive. There's nothing in there that can explode, but we might be corroding the
oven.
the heating elements. We might be corroding the oven, which is one of my concerns. So we're trying to keep it just to one test, see if this works in theory, and if not, we're probably gonna have to go with the anodizing method, where you put the sample inside of a aqueous solution of different materials, depending on which metal you're trying, and by applying a current through that metal, through the solution, similar to the way you do metal plating, you can also get an oxide to form on a metal that's already in there, just by having it negatively charged, and the oxygen gets pulled toward that, and the oxide then builds up on the surface. Actually, lots of materials are made like that. Like airplanes, when you see their outer shell, if you were to put electrodes on that metal, you would find that it's not conductive, because there's that oxide layer, a thick oxide layer of aluminum oxide, which is basically a dielectric. So what we're trying to do is make metal oxide, which is dielectric, and then have metal on top of that. And there you go. You got yourself a very thin film capacitor. And the hope is that with Alzofon, EPR electron paramagnetic resonance, we'll be able to get deeper penetration into a sample by having many different skin layers, because there's a skin depth issue where the RF only penetrates a very small amount into the metal.
So you have 3 team members, right? You've got 3 people on the team. And then you've got probably about 12 projects you're juggling right now, I think, something like that.
Yeah, we have lots of projects that we're juggling, simultaneously. We try to work on a little bit of whatever we're able to, like whatever the equipment allows, and timing and learning and whatever. Another thing I did is I moved most of the heavy science books. I took them out of the lab and set up a study at my house, the lab house, with lighting and everything, because I realized that I can't really study these science books in here. There's just too much going on. You need to be able to concentrate on this stuff directly.
Do you have like an easy chair? You need an easy chair, 1950s style, right? Big leather easy chair for fireside chats.
Yeah, I have a Natuzzi couch that has like the pop up, and then I also got something that's called a Stender. This is a Jewish invention. It's like a lectern. It puts the book directly in your face, and then you have a place for your feet to sit, so that you can read a book that is intense. It's not for light reading. It's for intense books, with math and with, hard to understand concepts. It sticks them right in your face, no distractions, just the book right in front of you in intense lighting, and you're able to dive through, basically meditate on the book, just like read it line for line and figure out what's going on.
You need a little holder for your brandy, right? Little table, little holder. You can, yeah.
I don't know, maybe a little pocket for the Adderall or coffee.
There you go.
Coffee actually goes very good.
This is my
But,
study right here. This is my study. I turned it into, I don't even know what to call it. I'm thinking about calling it MIB Studios, but
Men in Black Studios.
yeah, it's the tie. I got the tie. I have the suit coat, but it looks weird. So I've been universally told not to wear the
You
suit
guys
coat.
want a sneak peek? Let's see what the sample looks like. Ooh, got some bubbles. Okay, it's cooling off. It's at 366 degrees. Yeah, I'm gonna wait for it to cool off a little bit more, because if we let the cool air in too quickly, thermal shock will crack the the substrate,
Yeah,
the ceramic.
I think that's really, yeah, I think what you guys are doing is incredibly interesting. This is a giant first. I mean, you've put together, this is a collection of specialized projects, specialized equipment, specialized skills, right? And you're developing a lot of this yourselves, and you have been for 2-3 years.
Yeah, it's going on 2 years now that we've been really working on this in earnest.
This is Discovery Channel special waiting to happen. I'm serious. I just realized that. That's where I will see you next, is Discovery or History Channel. So
no, you'll see me next in Hawthorne, New Jersey, when you fly down here.
well, that's a separate discussion for after I stop recording. But yeah, at some point I will get over there.
And you're gonna bring your fancy Hasselblad camera. Was it a Canon, Nikon?
Nikon, yeah.
Nikon, yeah, Nikons are the best. I used to have a really nice Nikon camera. I think it was stolen or got lost or something like that.
Yeah, tomorrow is the car. Tomorrow I have the electrician, and I gotta, because right now I'm limping along, right? Like and I use the supercharger and that helps, but like I'm charging at 90% of what I drive. So every day it's a little lower, a little lower, a little lower, you know. I'm like, can I make it to the mall? No, I can't.
But doesn't the mall have a charger?
They have a different brand. It's called Volta. I have no idea what it plugged. It looks like somebody plugged it into a Nissan Leaf. I got a Tesla for compatibility, and the first place I go, they're not compatible.
So there's a little adapter that you can get, not for the high speed, but for the stage 2 chargers. There's a little adapter that you can put on those and charge your Tesla just like you charge it at home.
Okay. Yeah. I did find a supercharger network. So I can charge it that way, but now it's complaining that it wants me to create a Tesla account and put my credit card in for billing. And I can't do that yet until I get my registration. So I don't know, whatever. So it's plugged into the house, but
Most of the charging happens at home anyways.
yeah. And to be honest, once it's charged, I mean, I drove it around today. I had no issues at all, and I did exactly what I thought. I mean, I just errands. That's why I bought it. It's a great car for errands, I mean, people, they get these lifestyle things. They're like, I'm going to drive across the country. No, you're not, man. You're going to put 99% of those miles on it going to AM, PM to get like Slurpee in the middle of the night. That's what people do, it's the mall, it's the grocery store. I was like, that's why range anxiety is not really a thing, because
I mean, I had some real range anxiety. I took my Chevy Bolt to the Adirondacks, and I was able to supercharge on the highway. But once I got into the park, there was no chargers like whatsoever. And I came to the rental house and tried charging on the wall, and I blew the fuse.
uh-oh.
And then I had to call the landlord, and they came and flipped the fuse back on for me. And then I found there was an air conditioner unit that we weren't using, so I unplugged from there and plugged it into the with an extension cord into the car.
Okay.
So we were like sacrificing air conditioner for charging the car, and like every day we had to ration how many miles we would go because of how limited the charging infrastructure was up there.
Yes. That's where I'm at right now. Like, how bad do I need to get there? You know? So, yeah, no, it's
But
interesting. I mean, EVs are on their way in. It's like, I have this weird feeling that you give it another 5 to 7 years and the average person will feel really good about it, you know?
I think we were kind of there already where they feel good about it, just that they don't have the money for it. And the availability is like, it's not really there yet. There's not enough battery manufacturing, to really make it fully mainstream yet.
Yeah. I know what you're saying. Although when gas in my area, when gas started pushing $6 a gallon, I mean, the reason I got a Tesla was I started seeing them everywhere. And I'm seeing 5 to 10 Teslas a day still driving around. So
there's quite a few of them, and there's very few of them that aren't sold.
yeah. Well, Mark, thank you, sir. Thank you for the tour of the anti-gravity lab. I will put this up on my channel, and yeah, I'm excited. This is action footage for me.
Okay.